Question 9, part 1. We're given the area of a sector of circle of radius r centimeters is 36 centimeters squared, and we need to show the perimeter P is equal to 2r plus 72 over r. So at the top right in red, I've written out the formula for the area and perimeter of a sector of a circle. So the area is equal to 1 over 2 r squared times theta, and our perimeter is equal to r times theta. So our perimeter then is going to be this r plus the curve length, which is here, and that is just r times theta. So we need to write P in terms of r. So if we can find an expression for theta in terms of r, well then we can go about solving this problem here. So to start with then, we know our area is 1 over 2 r squared times theta, and that is equal to 36. So multiplying through by 2, well then we get r squared times theta is equal to 72, and divide through by r squared, so we get theta is equal to 72 over r squared. So our perimeter then, we know our perimeter is equal to r plus r, which is 2r, plus r times theta, and we know what theta is. It's 72 over r squared, so that is equal to 2r plus r times 72 over r squared, and that r will cancel, so then we're left with P is equal to 2r plus 72 over r. So that is what we wanted to show, and that is part 1 done. For part 2, we're given that r can vary, and we need to find the stationary value of P and determine its nature. So given that r can vary then, and we need to find the stationary value, we need to take the derivative of P with respect to r. So we've got our equation here for P. So taking the derivative of that then, with respect to r, we're going to get dP by dr is equal to, or 2r will just become 2, and then plus, well 72 over r, you can think of that as 72r to the minus 1. So multiplying 72 by minus 1, we're going to get negative 72, and then take 1 off the power, so yeah, we're going to get r to the minus 2, so that's the same as 1 over r squared. Okay, so that means we've got dP by dr is equal to 2 minus 72 over r squared, and we need to set that equal to 0 to find our stationary points, and then we can solve this for r now. So multiplying through by r squared, so we're going to get 2r squared minus 72 is equal to 0. So therefore 2r squared is equal to 72, and divide both sides by 2, so r squared is equal to 36. So r is just equal to the square root of 36, and we're just taking the positive square root because a radius has to be positive because we're dealing with a length. So therefore r is equal to 6. So the stationary value of P then occurs when r equals 6. So we just need to find that value of P. So when r is equal to 6, well P is equal to 2 times 6 plus 72 over 6, and that's equal to 2 times 6 is 12 plus 72 over 6 is 12, so therefore P is equal to 24. So that's the stationary value of P. So now we just need to find out whether this stationary point is a maximum or a minimum. So to do that, we're going to take the second derivative of P with respect to r. So the second derivative is just the derivative of the derivative, which was this part here. So that's going to equal then, well the derivative of 2, well that's just a constant, so that's going to just be 0. And then we want to take the derivative of this negative 72 times r to the minus 2. So negative 2 times negative 72, well, that is positive 144. Take 1 off the power, so that r to the minus 2 becomes r to the minus 3, which is the same as 1 over r cubed. So we get 144 over r cubed. And we know that is greater than 0 because r is equal to 6 at this stationary point, so r is definitely greater than 0. So if our second derivative is greater than 0, then our stationary point is going to be a minimum. So we'll just write that down. And that then completes question 9.